Hello everyone. So this is the sample question paper that I have created by taking the reference of the paper in the academic year 2020-21, and that time the syllabus was vector differential calculus. That means what is a vector function, vector fields, gradient fields, then the operators gradient, curl, Laplacian, divergence, directional derivative, and little bit of line integral. So that was the syllabus. So here is the first question. What to do is, you will once you see the question, you pause the video, think over it. What will be the solution? If you want, you can solve in a pen or paper or in your brain, depending upon your own convenience. And after seeing your solution, you can just play the video and you can see my solution as well. Okay. And if you find any calculation mistake, then do not forget to post in the comment section. Okay, so the first question is you have to find the divergence of the vector function or the vector field. So what is my f over here? It is nothing but if I take this term inside, I have x cube y square z square, I have x square y cube z square, and I have x square y square z cube. Fine. And what is the divergence of a vector field or a vector function? You differentiate first component with respect to x, which is x cube y square z square, plus you differentiate second component with respect to y, which is x square y cube z square, and you differentiate the third component with respect to z, x square y cube, sorry, y square and z cube. And I think from here it is easy. The first is 3 x square y square z square plus again 3 x square y square z square plus again 3 x square y square z square. So your answer will be 9 times x square y square z square. So this is the answer for the first question, and I think this, if at all such kind of question comes, it will come for 1 mark because you have to simply take the partial derivative. Okay, so this was the first question. Let's go for the second question. So here you are supposed to find the parametric representation of the surface. Now, what is a parametric representation for a surface? So now you know that this is a plane in three-dimensional space, x, y, z axis. I want to define a function r from a two-dimensional space. So we always take one-dimensional less, right? So this is my uv plane. This is my x, y, and z plane. So I have to define a parameterization. So here R, it will take u comma v, and I have to parameterize this surface. So something x, something y, and something z. So one way is you put x equal to u, y equal to v, and from this relation one can see that your z is nothing but 5 minus x minus y, but my x and y are u and v, so 5 minus u minus v. Now there is no restriction on this plane, so therefore no restriction over here as well. Your u and v are any real numbers. Okay, if they say that your x is from 0 to 5 and y is from -1 to 1, accordingly the same restriction would have come to u and v as well. Now this is one parameterization. Another parameterization can be you call y as u and z as v, and then you write x in terms of y and z and then u and v. So that can be the another representation. So one can have plenty of parametric representation for this given surface. So if this question, if at all comes, this will also will be for 1 mark because you have to simply take uv and you will get z from this relation. So I hope this example is also clear. Now let us go for the third example. Now in this third question, we want to find the normal vector to the surface this. So this is the surface given to you and the point is given to you. So what is a normal vector? We know that the normal vector is nothing but the gradient vector. So here simply you need to find the gradient vector, which is nothing but f with respect to x, f with respect to y, and f with respect to z. And what this will be with respect to x? This will be nothing but 2xy plus y square. F with respect to y will be x square plus 2xy, and f with respect to z will be 2z, right? And what will be the normal vector at the point 1 comma 1 comma 1? So you replace your x y z by 1 comma 1 comma 1. So your answer is 3 comma 3 comma 2. So this will, if at all such questions come, it may come for 1 mark because, or 1.5 mark. So this is what the normal vector is at the given point. Now let us go for the fourth question. So here it is given that a vector field is given which is conservative, and you have to find the value of this number b. Now, when a vector field is conservative, if you recall a theorem in line integral, a vector field is conservative when its curl is 0. Okay, so it is given that the curl of this vector field is equal to 0. What is the first vector? First vector is nothing but the nabla vector, dabba by dabba x, dabba by dabba y, and dabba by dabba z. Here you have e raised to x z minus bxy, 1 minus bx square, and e raised to x plus bz. And now I think this is easy. This is I into what is with respect to x you get with respect to x if you do. So this minus this. So with respect to y, sorry. So with respect to y, this will be 0 minus with respect to z, this will be 0 minus j into you have only e raised to x and minus you have e raised to x only, which is again 0, plus k into you have minus 2bx, and minus when I do with respect to y, I have bx. Correct? If I'm not wrong, this might be a plus sign over here. So this is equal to 0. 0 means 0 vector. Now from here, what you have? The k component is nothing but minus 2bx plus bx. So you have bx equal to 0. Okay. So this is true for all x. So when my x is non-zero, this implies that your b has to be 0. So when your b is 0, only then this vector field is conservative. Okay, so I hope this is clear. If you feel my calculation is incorrect, you can definitely correct me in the comment section. Okay, cool. Let's go for the next one. Here is the fifth question. A normal vector to the surface. So in this case, a parameterized surface is given to you. At the point 0, comma 0, you have to find the normal vector. Okay, so how do you find the normal vector over here? For a parameterized surface, you take the cross product of two vectors. What are those two vectors? It is r with respect to u and r with respect to v. So you take the tangent vectors in the direction u and v, and then you take their cross product. So when I do with respect to u, this will be 0, 0 and 1. And when I do with respect to v, it will be minus a sine v, this will be b cos v, and this will be 0. Okay, so what is this? So I have I into minus b cos v minus j into a sine v plus k into 0. Correct? And at 0 comma 0, when I do, my cos 0 is 1, sin 0 is 0. So minus b comma 0 comma 0, or minus bi, or minus bi plus 0j plus 0k. So this is what the normal vector to the given surface is at the given point 0 comma 0. Okay, cool. So this might come for 2 marks, but okay. Now let us go for the, so this was the fifth question. Now let us go for the sixth question. Now, what is the given to you here is a vector field is given to you. You have to find nabla cross of V. So, if V is a vector field, what is the nabla cross V? It is nothing but the curl of V. So, I have to find nabla cross of V. That means I have to find curl of V. So, how will you find curl of V? So curl of, first I have to find curl of V, and then again I have to find its curl. So I, j, k. Okay, here you have dabba by dabba x, dabba by dabba y, and dabba by dabba z. What do you have here? X square y minus 2xz and 2yz. Fine. So what is this? This is I into, first I have to take this minus this. So I have 2z plus 2x minus j into, I have 0 minus 0 plus k into, I have minus 2z minus x square. Okay, so what I get is 2x plus 2z comma 0 comma minus 2z minus x square. So this is nothing but the curl of the vector field. Now I won't be solving this ahead. You, now the next step is you have to find curl of V. So I think you have the idea. If you want to do practice, you can definitely do the practice. The first row will be ijk, the second row will be the partial derivatives, and the third row will be this thing 2x plus 2z 0, and I think the last term was minus 2z minus x square. Here dabba by dabba x, dabba by dabba y, dabba by dabba z. You find the vector, whatever answer you get, that's the answer. Okay, so I hope this is clear to you. Now let us go for the seventh question. So now you have to the directional derivative of divergence of u. So you have to find the directional derivative of which vector field or which scalar field divergence of u at the point 1 comma 2 comma 2 in the direction of outward normal vector to the sphere for u bar equal to this is. Okay, so first thing is you have to find the divergence of u. So let us first find the divergence of u, which is dabba by dabba x of the first x raised to 4, which is 4x cube, plus dabba by dabba y of second, which is 4y cube, plus dabba by dabba z of the third component. So this is the divergence of u. So I have to find the directional derivative of divergence of u. So in this case, what is the scalar function? Your scalar function is nothing but this divergence of u, which is 4 times x cube plus y cube plus z cube. So this is your scalar function. Now what is the formula for directional derivative in the direction v bar? It is nothing but grad f at v bar, sorry, the grad f at the given point. So here it is 1 comma 2 comma 2 dot product with the directional vector, and we should note that this should be a unit vector. Don't forget to convert this into a unit vector. Okay, so this is the formula we have. So now first thing is you will find the gradient of this function. So what is the gradient of this function? So I will find grad of f. So it is nothing but function with respect to x. So that is nothing but 12x square, comma 12y square, comma 12z square, right? Because 4x cube derivative is 4 is a 12x square. Now what is grad f at the given point? The point given is 1 comma 2 comma 2. So this is nothing but 12 comma 12 4 is 48. 12 4 is 48. So this is what the gradient of f is. Now question is what is your v bar? Now the directional vector is given to you indirectly. Okay, the direction is what? It is outward normal. So I will take plus grad f. If they would have said inward normal, then you would have taken minus of grad f. Okay, minus of grad of this function. Not grad f, minus of grad of this function. Okay, so I have to find the normal vector to which surface? The surface G is x square plus y square plus z square minus 9. What is the gradient of G? It is 2x, comma 2y, comma 2z. And what is the point given to you? Point given to you is 1, comma 2, comma 2. So if I do 1, comma 2, comma 2, I have 2, comma 4, comma 4. And when I divide by its length, mod of grad G, it is square root of 4 plus 16, which is nothing but 6. So your V bar is nothing but gradient of G upon mod of grad G, which is 2 by 6, 4 by 6 and 4 by 6. Right? And now I think you simply take the dot product and you get the answer, right? So if I do it over here itself, grad f dot v bar. Okay, so 12 into 1 by 3, which is nothing but 4, plus 48 into 2 by 3. So this is nothing but I think 32 plus 32 if I'm not wrong, and you will get 68 as an answer. Okay, so this was little bit of tricky. This might come for 3 marks. Okay, so thing was easier to find the directional derivative, but many things were given in a way around. Okay, fine. Now let's go for the eighth question. Here you want to find the line integral. What is the vector field given? Y square comma x square. What is the C? C is the straight line segment joining the points 0, 0 and 1 minus 1. So this is the point 0, 0 over here, and this is the point 1 comma minus 1. This is the segment, and this is the direction. So how do you parameterize a line? The formula is it is 1 minus t into the first vector plus t into the second vector. So it is 1 minus t into the first vector is 0, 0 plus t into the second vector 1 minus 1. So there is nothing but t into this part is 0. So this the second part remains. This is t comma minus t. And what is the value of t? T is going from 0 to 1. Okay, so 0 less equal t less equal 1. And now it's easy, right? You simply apply the definition of line integral f dot dr. What is this? This is nothing but integral t is from 0 to 1 f of r of t dot product with r prime of t. Correct? What is r of t? It is t comma minus t. So what is r prime of t? It is 1 comma minus 1. What is my vector field f? For vector field, if you see, it is y square comma x square, y square comma x square, and your r of t is nothing but t comma minus t. So what will be f of r of t? Wherever you have x, you replace your x by t. Wherever you have y, you replace your y by minus t. So this will be t square comma t square. And if I take the dot product of f of r of t with r prime of t, this is nothing but t square minus t square, which is nothing but 0. So this is nothing but integral 0 to 1 0 times dt, which is nothing but 0. So the work done is 0 units. Okay, so I hope this part is also clear to you. Now let's go for the ninth question. So in this ninth question, what you want to do, you want to find the line integral again. Now what is the c? It is the boundary of the region. You have to take y equal to 1 and y equal to 2 minus x square. So what is y equal to 1? Y equal to 1 is this horizontal line over here, right? And what is y equal to 2 minus x square? It is this inverted parabola. So this is my 2, and if I put y equal to 1, this is my point 1 and minus 1 over here. So this point is minus 1 comma 1, this point is 1 comma 1, and it is going in the counterclockwise direction. So it is going here. So this is the line like this, and this is the curve like this. So this is the thing. Now I want to find the line integral. Now, if you have seen the Green's theorem, then one can use the Green's theorem because the region is closed and bounded over here. So one can use the Green's theorem. If you don't know the Green's theorem, then you call this region as C1 curve, this curve as C2 curve. You parameterize C1 curve, which is a straight line segment, and you know how to parameterize the straight line segment. It is 1 minus t into the first vector, which is minus 1 1, plus t into the second vector, which is 1 comma 1. Okay, then you use the same definition. Similarly, for C2 also, you can parameterize. It's a parabola. So if you take x equal to t, your y will be 2 minus t square, and t is going from minus 1 to 1. Okay, so you can do this along C1 and along C2, and then you add it up. That will be the line integral. But now, since the earlier question I have done by this line integral definition, let me do this by Green's theorem. So what does the Green's theorem says? If you have the closed simple curve C, and if I want to do the line integral, then that is double integration over the region R. What is the region R? It is my region enclosed by the curve C, and you do the second component. So if my vector field F is P comma Q, you do second component with respect to x minus the first component with respect to y, and then dA. Okay, so in this case, now double integration we have already studied. So if I want to find the limits of y, what I will do, I will draw the line parallel to y axis. So y is entering from y equal to 1, and it is leaving out from 2 minus x square. So y is going from 1 to 2 minus x square, and when I project this, I get x is from minus 1 to 1. So my x is going from minus 1 to 1. Okay, now what is the second component with respect to x? So this with respect to x is nothing but 2x, and this with respect to y is minus 2y, right? So you have 2x with respect to x, and what is this with respect to y? It is minus 2x. So minus of minus 2x, and here you have dy dx. Okay, I hope my calculations are correct. This with respect to x is 2x, this with respect to y is minus 2x. So this will be 4x. So let me take out 4 outside. This is the limits of x, these are the limits of y, but x is outside, so I have 2 minus x square minus 1 times here the dx. So 4 times 2x minus x cube minus x. So this is x minus x cube, and you can see that x is odd function, x cube is odd function, limits are from -1 to 1, answer is 0. If you don't know, you can simply calculate, but yeah, the answer is 0. So this is one of the simplest way by using Green's theorem. And if you don't know Green's theorem, you can simply use integral along C1 and integral along C2. Okay, cool. Now let's go for the last two questions. You have to find the value of curl of this vector field. So what is r bar? R bar cos of r. What is r bar? X, y, z. So x cos r, y cos r, z cosine of r. What is r? It is mod of r. So this is x cos of square root of x square plus y square plus z square, y cosine of again square root of x square plus y square plus z square, and z into cosine of square root. And now I have to find nabla cross. That means I want to find the curl of this vector field. Okay, so this I'm not going to solve because this will take a lot of time, which I don't want to waste. I know your time is precious, so I will simply write down the formula over here and you can do the calculation. Needless to say that if you get stuck, you can ask me in the comment section. So this is x cos of root, your y cos of root, and z cosine of root. Now simply do the cross multiplication, apply chain rule, and you will get the answer. Okay, so that's the hint I would say for 10th question. And yeah, here is the last question for you for 3 marks again. I have to find the work done by the force. Okay, so the vector field is given to you. When it moves a particle from 0, 0, 0 to this, and the curve is also given to you. So what is the parameterization given to you? 2t square comma t comma t cube. What is the limit for t? As you can see, when my t is 0, I get 0 comma 0 comma 0, and when my t is 1, I get 2 comma 2 comma 2. Okay, so my r of 0 is 0 0 0, and my r of 1 is the point 2 comma 1 comma 1. So my t is going from 0 to 1. Okay, what is the next step you do? You find r prime of t. Correct? So what is r prime of t? You take component wise derivation, which is 2t square is 4t comma 1 comma 3t square. You find f of rt. So wherever you have x, y, z, you replace your x by 2t square, y by t, and z by t cube. So you have 2y plus 3. So you get 2t plus 3, right? You get 2t plus 3, comma, you have x into z. So 2t square into 2 into t cube. So you have 2 times t raised to 5. Then at the end you have yz minus x. What is yz? T into t cube. So t raised to 4 minus 2t square. So you have t raised to 4 minus 2t square. Now you take the dot product. F of r of t dot product with r prime of t. Okay, so what you have, you take this multiplication. So 4 2s are 8 t square plus 4 3s are 12t plus 1 into 2 raised to 2t raised to 5 plus 3t raised to 6 minus 6t raised to 4. Okay, so finally the line integral is p is from 0 to 1, the dot product. First, you should always mention the formula, okay? Otherwise, people might cut your marks. So, this is the dot product you get. And now I think integration is quite easy. You can simply do the integration and you can, if you're not lazy, then I would be happy if you comment the answer in the comment section. So this would, I would say, the sample question paper for 20 marks. If you have any other questions in which you have doubt, then you can definitely ask me in the comment section. And the link for the videos related to these questions you can find in the comment section. Thank you.